Okay. So last time we saw two different ways of sharing. We saw an IM tool, and we first saw an echoing tool. That was just single user. Then we made that into an IM tool. That was multi-user. And that IM tool we shared in two different ways. One was you had some, I said there are twin goals of collaboration technology. One is towards being there, and one is going beyond being there. So the first one was fairly loose coupling, where it wasn't as if you were right there. If I scrolled my IM window, you didn't scroll your window. If I resized it, you didn't resize the window. But yet we had some kind of coupling. Okay? So that's going beyond being there, where you actually see everything, share everything. Okay? And the second one was the more closely coupled system, where my cursor positions, my window changes were being reflected on the other side. And I said that if you haven't used Skype, you've probably used remote desktop, and this technology is in that spirit. Okay? And the second technology, the first implementation was specific to the application. Okay? Whereas the second implementation, where you were just sharing windows and events in Windows, was based on a certain window system, which is the Java AWT Swing window system. It was not based on an application. That means the same technology could be used to share any application that uses Swing or AWT windows. Okay? And that is what I showed you essentially. And this demo shows you that, look, this is a very different application. It's just some collection of random widgets. And you can see that when I move my cursor here, it's going and being reflected at elsewhere also. Okay? So this shows you that indeed even the telepointer is pretty much independent of the exact application. Okay? Now, building such systems is not easy. It's pretty hard. In fact, for every class of systems, there's typically a separate paper. Okay, I did this for X. I did this for lots of old systems that you guys don't know about. But basically, these papers came out in the late 80s or early 90s, and there was a separate paper almost for each kind of system. And I found a way to do it for Swing and AWT, which doesn't work perfectly, as I was demonstrating to you last time, mainly because AWT and Swing were not meant to be made collaborative, which is kind of a pity, because Java came after this kind of technology was invented, and a lot of my friends who work in collaboration software were in Sun, and yet they didn't quite make it easy to make it collaborative. Okay? So we saw that there were some problems with JText field. The character, I couldn't move the cursor around. But in principle, you see how this stuff works. Okay. Now, here's the window that I've been not really demoing, but you've seen it. What do you think these four components here are? What do they have to do with the demo? So let's look at the first thing: session manager, server starter. Session manager. What could that mean? Nick?
It's like Alice, Bob, and Kathy right now all have sessions, and that's how they're able to access the shared information. So the session manager is like a centralized tool that's managing all the users.
Yeah, exactly. So the idea is that what is the scope of my collaboration? Alice, Bob, and Kathy are all collaborating with each other. David isn't here. Just how come, when you think of a program, a single program running on a single process, the scope is well defined. Okay? What happens when you have multiple programs talking to each other? Somehow we need to define a scope for that. And a session is a scope, essentially. And somehow these three processes, and I'm simulating, essentially, not simulating, I'm really implementing the same implementation could run on different computers. It's running on a single computer here. So I'm not really simulating. I'm just executing this all on one computer so that I can demo it. And the session manager is defining the scope, and then you can figure out what these other three programs are, right? Each of them is a JVM, essentially. Okay? And JVMs use the same primitives to talk to each other on the same machine or on different machines. Okay? In fact, sometimes it's harder to do it on the same machine. or at least less efficient. So that's a session manager. And then you have these three other processes that know about each other through the session manager. Now, what about, when I go and move the cursor here, move the telepointer here, this is Alice. Alice's process gets the event. Somehow that event is shown by Bob's process and Kathy's process. How do you think the communication went? What are the choices that I might have? What are some buzzwords that you might have heard in distributed communication? So somehow two processes are talking to each other. They could talk to each other directly, and that's called P2P, peer-to-peer, or they could talk through a server. Okay? And we don't know from the implementation what's happening here, but what do you think should happen? Should each process send the events to the different processes directly, or should it send it through a central process like the session manager? We know there's a session manager server that is defining the scope. Maybe it can also be a relayer and be relaying messages among the processes. Okay? And when I pose this question, the answer is depends. Okay? There are all kinds of trade-offs here. But what instinctively in this kind of system where I'm sharing telepointers, what might you do? Okay?
I think if we don't want the user to be aware of all the other users, then it's better to put it through a session manager.
Okay, so you're talking of programmer, the programmer or the user?
The programmer.
The programmer. So you think that you're thinking like a software engineer, and you're saying you want to make your task easy, and your task could be made easier if it's gone through the central process. As it turns out, I'll give you an abstraction that'll take this all away from you, and you won't even know whether you will just specify which way you want to go, and then the same program will work both for peer-to-peer and through the server. Okay? So if you didn't design it, if you didn't design that abstraction, indeed you'd be right. But as it turns out, I have designed an abstraction that hides that from you, and you just say, I want to share among these processes, and it'll decide whether to do peer-to-peer or to the central process. Okay? So from a programmer point of view, unless you had my system, okay, and there's no other system like this, so there's in the traditional state of the art, indeed what you'd be saying is true, but this is a research system. What about other factors? One is programmability, the other might be. So if you are the programmer, you care about certain things. If you're the end user, what do you care here about? Performance, maybe? Okay, you care about the user interface too, but the single user interface was designed for you. The multi-user interface, we've kind of decided that everything's being shared. Everything we can share, we will share. So then performance may be an issue. And the performance would be better if you talk directly, right? Because you don't have to go through a server and come back. And one of the guys who's really in this area, really, says this again and again, is a guy who used to be in Australia at one time, and he said, look, if your central server is in the United States, and I have to go through it to talk to two Australians, and maybe there's some people in the United States also, just the speed of light will get in the way. Okay? Forget all the routers that go on the way and delay messages. Okay? So you might be doing it directly. So that's the advantage of peer-to-peer. The advantage of peer-to-peer also is from an infrastructure point of view, that you have 4 people, you decided to collaborate in the airport, and you've got your mobile smartphones. You're not going to be able to set up a server, and one of them, the server on one of the machines might, will go down when the person catches their flight. So the mobile computing guys love peer-to-peer also because it's less infrastructure oriented, and mobile computing typically means that you have as few dependencies on wireless connections, on connections as possible, and on specified hosts. Okay, so indeed, in this architecture, they're talking, in this implementation, they're talking directly to each other. Okay, so when they're talking directly to each other, we can talk about the delays from one process to another process. Okay, and here you see that I have gone and put an extra delay between Alice's process and Kathy's process. Okay, so Alice's process to Bob's process is going as fast as it can. Okay, but to Kathy, I've got a delay and a delay variation. Okay, so I'm putting a 300 millisecond delay, and I'm saying, in addition, there can be some variation between 0 and 300 milliseconds. Okay. Is that, by the way, a realistic delay? Anybody know from networking? So when I work in India, I ping American sites, and it's between about 400 milliseconds. Okay, so this is realistic delay. So if that's the case, you should be able to see some difference between Bob and Kathy should experience a different kind of experience, have a different kind of experience. Now, the delay, of course, is going to just mean that the other, one user is seeing things after a while. And the delay variation is going to cause what kind of problem? So one is going to cause latency problem. And what term might you have heard for a bad thing that happens when you have delay variation?
Jitter.
Jitter. Okay? So you can have jitter. And so jitter means basically things are not going smoothly. Even if at one end it's smooth, the other end it may not be smooth. Okay? So they're going at a rate that's different from the rate at which these sending site send information. Okay? So let's go and see whether we can see any. We'll see the delay for sure. Jitter depends. The way I've implemented this, we just pick a random number between 0 and 300 milliseconds for the variation, and who knows what it'll actually pick. But let's go and see some difference. Actually, I forgot that forget that you saw that. So let me remove the delay variation, and you'll see that it's much smoother at Kathy's end. Okay, it's just a little later. Okay, and it's not such a big problem. Kathy doesn't know when Alice started moving, but when I go and put the delay variation, you'll see that it's more jerky at Kathy's end. Okay, I don't know whether you saw it or not, but that's what happens. Okay, so how do you overcome? By the way, how do you? This is a problem you will face even when you download a picture from Netflix. Okay, you don't want you don't want to have jitter, and typically, what's the answer to jitter?
In Netflix, it buffers.
You buffer. Okay, you just say I get enough data, and I'll just show it at that rate. And of course, and the problem with buffering is it's not real time there. Okay, so how much can you buffer here? You don't even know what Alice is going to do, how long to buffer. And so that's a traditional approach. And you kind of saw a solution that, a UI solution that was created for this situation, which was to basically, when you're telepointing, you're trying to circle around or point at something. So just don't show one telepointer at the remote and show a trail that the telepointer took. And that trail is persistent. So with jitter, you might not see the trail properly, and so if you, you might not see the trail with jitter and only one telepointer shown at one time, you might not see the trail properly. But if you show the history of the telepointer positions, you might see the trail properly, and that's what's happening here. So you see a trail that goes down, and I can just make this more dramatic by making the trail longer, and I don't know what's the right number here. My demo is not as nice as the original paper that I saw in a conference. Maybe I haven't implemented it right, but see, now you're seeing the trail, and you can see the path I traced, and notwithstanding the jitter, the point has gotten across to Kathy. Okay, and so this is a UI solution to a distributed systems problem. So I kept talking about collaboration technology being a union of interaction technology and distributed technology, and this is the most compelling example I have. Assuming you found the UI compelling, this is the only example I have where really one is trying to neutralize the problems with the other. Okay, so this is the trails, and I want to just show you also why this shared window system doesn't work as well, and why this telepointer also is not totally application specific. So if I move the telepointer to here, it's gone away. Okay, bring it back here, it works. The reason is that I've used some technology that was invented in the context of swing, and these widgets are swing widgets. These are AWT widgets, and AWT widgets will hide the telepointer. Okay, so when you guys do the telepointer, you should be aware of this. And then I showed you other problems last time. Okay. Okay, so let's end this demo. Any questions about this demo? Remember, I'm going to ask you guys to vote on the demos. Okay, one or two projects I want to eliminate from here. So you've got to figure out which one you don't want.